Hi folks, and welcome to Sailing KYAN II. Today we'd like to talk about solar energy. I'm sure everybody is finding this to be a hot topic. Many of you already have it on your vessels. Some of you are looking to do those winter projects, which we are now. We'll talk about the charging methods, the application, what we think we're going to be using, and why we purchased it. And then finally, the one last thing I wanted to do is to mention why there's a can of sea foam behind me, and that's pretty simple. If you haven't put the sea foam in the tank by now, you better run down there and do it if you're winterizing. If you're not winterizing and you're traveling, do it anyway. It never hurts. So to get started on solar, the first thing you need to do is calculate your energy needs. So we conducted an audit of all the devices we use on a daily basis. We excluded the windlass since we always run the engine anyway. When you see your dependency on energy this way, you quickly realize the importance of calculating carefully and generously. So for energy generation, we used a best case, worst case scenario on a 24-hour period. Our best case scenario showed a small surplus of energy. Our worst case scenario, with zero solar and 25 amps from the engine, depleted our battery bank to 155 amps. Putting this in perspective, this is approximately a 50% depth of discharge, which when using lithium batteries is a great place to be for recharge purposes. We added a 10% plus or minus factor for usage. Of course, if we need to, we can reduce that consumption considerably and extend our endurance. Using the generator as shore power, we have the fastest recharge time of 2 hours. The charger inverter will charge as high as 75 amps on shore power. The system is good for backup if you have a failed alternator or you have a solar module failure. So everybody has their own preference of charging in solar. Ours is to use a hybrid solution and enjoy the comforts of life while sailing. We chose the Renogy panel for a number of reasons. After looking around the marketplace on Amazon and various places, we were very concerned with the warranty that was available. We're very leery of spending that type of money on a panel or any product that doesn't come with an endorsement and that we don't feel is going to be around in 3 to 4 years. Solar panels are, at the best of times, predictable. They can be damaged by impact, they can be damaged in weather, and of course they degrade as time goes on. Now before we start, I just want to mention this is not a paid commercial or an advertisement for Renogy. When we looked at Renogy products, information was easy to obtain and the knowledge base and the forums were very helpful. We ordered online, we experienced good service, we just have a good feeling about their products and hope that we're not disappointed. Since we decided to use our Bimini top to mount 4 100-watt panels, we like the feature of being lightweight and flexible. With a weight of less than 5 pounds, we figured they'd be easy to install. Also, since heat buildup can be an issue with any flexible panel, we think we've got a solution for this, which we'll show you in part 2 when we do the installation. Since we learned that flexible panels have a shorter lifespan compared to other panels, Renogy's efficiency warranty was a major factor in our buying choice. If Renogy stays around for 25 years, they could possibly be the best warranty in the business with their 5-year 95% warranty. So using 4 100-watt panels wired in parallel gives us over 21 amps to the MPPT controller. Some of you may remember trying to find that one burned out light on a Christmas tree. Well, it's the same issue when you wire solar panels in series, and everyone knows how good sailboats are at casting shadows. So it's sayonara to the power. The pro to wiring solar panels in series is that the amp draw remains constant, making longer cable runs possible without increasing the wire size. In our case, the distance from our Bimini to the controller is less than 20 feet, making parallel the best solution for KYAN II. The subject of controllers is interesting. There are PWM controllers, pulse width modulation. There's MPPT controllers, which I'm not going to claim to remember what that stands for. But the MPPT controller gives you a much better amperage output. There's also the question of when you're looking for a controller is there something else you want to do with that? Well, in most cases in marine and RV application, you want to charge a bank of batteries. If the batteries vary, for example, if you have flooded cell batteries in your boat today, as we have for years and we're getting rid of those, we want to switch to a lithium phosphate battery, which we're doing. But we also want our start battery to be an AGM battery. So when we're looking at charging an AGM battery will charge from the engine alternator. So there's a product out made by Renogy, which is basically a DC to DC charger with MPPT controller. And what that basically does is allows our engine to run, charge up the starting battery. Once the starting battery is happy and it has its charge, it moves over to the lithium batteries, and it charges up to 25 amps. At the same time, it's taking the charge from the solar panels, which is up to 25 amps because we're using 4 100-watt panels up there, and it evens out the circuit. And then when those batteries are full in lithium, it allows the trickle charge back to the AGM battery. Now all of this you can perform while you're running with one AGM and up to 4 parallel lithium phosphate LifePO4 batteries. We looked at the option of going with an MPPT controller only and charging our batteries separately. We actually made the purchase of the MPPT 40 amp controller before we realized that the DC to DC charger was a better option. The 50 amp DC to DC charger allows you to isolate your start battery from your house bank, provides charging of the house bank, and trickle charge back to the start battery. Best of all, it allows the use of mixed battery types. It uses MPPT charging to maximize the charge. Connecting the device is straightforward as there are 4 lug terminal connections. Just make sure you pay close attention to the order in which you connect these, as connecting the solar first may cause some damage. The first connection is the common negative, NEG negative, which is for the solar panel, starter, and bank batteries. The second connection is from the house battery to the terminal marked out plus. Always make sure that this is the first battery in any parallel configuration. The third connection is from the starter battery to the terminal marked ALT positive. If you have a smart alternator, check the guide for instructions on how to connect. The last terminal connection is for the positive wire from the solar panel. Don't connect this until all the other components have been connected. There are also connections for the battery temperature, voltage, and smart ignition sensors. When you use lithium batteries, no temperature sensor is required. The Bluetooth connection is made with the RS485 connection. The app downloads for free and will allow you to make all the necessary system customizations. We looked around at Battleborn, we looked around at everybody. We said, why are we spending $900 for a 100 amp hour battery? Didn't make any sense to me. We visited a couple of websites. Will Prowse, who has a fantastic website, seems to be very knowledgeable. We follow him on YouTube. He has some great information. We found a battery source called SOK. I think we purchased our batteries for under $600. They take about a month to get here. They have a great review on their website. We can put a link in later to show you where that is as well. So we've ordered 3 100 amp lithium phosphate batteries to go along with our 1 100 amp AGM battery. Our 3 batteries arrived exactly 14 days after we placed the order. We were impressed with the double case packaging and the extra closed cell foam they used for packing. Our volt test on each battery produced between 13.01 and 13.04 volts. Not a bad job. A charger inverter is a definite game changer when it comes to life on a sailboat. Used wisely, the possibilities are endless. Besides being able to make margaritas, we can cook using induction, make morning coffee, plug in our laptops, watch TV, and even do laundry. When on the water, this charger inverter provides a faster way to recharge using any generator. No need to worry about power interruption when switching power sources, and it's auto start capable for those generators that come with that. You'll need some space to store it though. It's a beast and weighs 65 pounds. It comes with a remote switch so you have the option to control it if it's mounted in a hard to access spot. The key to using an inverter wisely is to understand the precise amount of energy to be used. Calculate the estimated minutes of runtime for each 120 volt device and keep it handy for future reference. Divide the watts by 12 volts to determine the amp hours. Then add on the energy cost of the inverter, which in this case is 10%. Now divide that amount by 60 and voila, you now have your cost per minute of energy. Mixing our margarita costs less than 1% of our total energy bank. That's a lot of margaritas. Of course, don't forget to calculate the cost of making the ice. After researching solar panel configurations and methods of attaching them, we determined a simple criteria list. 1, we had to avoid cutting into the new bimini top. 2, we needed to find an attachment system that would survive 30 to 40 knot winds. And 3, something that's easily removable in the event of an emergency.
As long as the distance between here and here equals the distance over there, I'm happy.
Well, after spending some time discussing our options, we designed what we hoped would be a successful attachment system, albeit on the fly.
Here, and we'll attach all the panels the same way. So these ties are permanent, these are removable. This sits on top of the bimini and will get secured with white grommets like these all around the side. So we have our choice of where we want to wire it up and fix them to the deck with eyelets. So what we've done is we have made a cover to go over the bimini cover, and we've attached the solar panels to the cover over the bimini cover using the Sailrite locks buttons, which are very easy to operate. You simply pull and release, and they snap and they stay in place. We've put a total of 24 locks buttons on here. The centers of the panels, we have 2 Renogy 100 watts, 2 Asian 200 watts, and 2 more Renogy 100 watts, giving us 800 watts in total. And our wires will run down the center. This top will be grommetized in the corners. As you can see, we've custom made each white grommet to a tag, and this tag and the grommet is held in place with a super strength industrial plastic fastener, zip tie, and we'll be putting grommet holes in the corners and down the middle, and then we'll attach this cover to the deck of KYAN II using a half eyelet with screws and 5200 so it will never come out, and then we'll be able to tension it up. So the nice part about it is, once we decide to remove the panels, all we have to do is cut these zip ties right here, like so, and like this, and then simply undo your fasteners. So we go 1, 2, 3, and 4, and our panel comes off.
For our engine start battery, we chose to use a pair of 50 amp hour AGM batteries, sold by the Home Depot under the brand of Mighty Max. 25 years of aviation has taught me the value of redundancy, so wiring 2 of these in parallel ensures an additional margin of starting power safety in the event that one battery fails.
Okay. Perfect fit, and they're all solid, they're dry. That's the 4 in there, and these are dedicated for the engine, and they will hook up to the MPPT controller, which is going on the other side. These are 2 of the 3 house batteries, and now we have to position the house battery at the front before we can get all that done. So it turns out that our standard battery box is just a tad too narrow to put that battery in. So we're going to go and hook up the inverter, come back to this problem in a little bit. Let's see what we can get started now and get our cables ready for the inverter. So today we've completed our A&L fuse holder construction. Very simple apparatus. Simply take a piece of HDPE or wood, add 2 bolts to it, countersink them 5/16 and washers, lock washers, nuts, and nylocks. And they will fit perfectly, and you could then mount them anywhere you want. Just tighten these down, put the screw holes in, and voila.
Making custom length battery cables is easy, and you don't need an expensive investment in crimping tools for a one-time job. We use this simple hammer crimper and a 1-pound hammer. For an extra layer of safety and reliability for the lug, it's a wise idea to add a silver braze before you add the heat shrink tape. You never know, it might come in handy someday at sea.
We've got 2 start batteries in parallel, isolated from the DC charger. We have 2 lithium batteries, 1 and 2. A third one will go forward. Now, I want you to see what I found here on the manual. So on the manual, it shows AC input, AC output. Regardless of the arrows go the wrong way, the AC input looks correct, and here we're seeing load, we're hot, neutral, and ground. Here, when we look on our connections, we see neutral, low, and ground. So they're saying, when connecting, wire it just like the picture below. Well, I checked these anyway before I went ahead and wired it because I could see the difference, but I could see how somebody, unassuming, would end up getting that wrong. And don't forget the fine print. Be careful of the positive and negative poles. Reversing the poles might cause permanent damage to the inverter. It will surely blow the internal fuse. Well, they're not telling me how to fix the internal fuse yet. So, let's see if we can get this wired up. Alright, black goes to the ground, and this goes to our hot. So that's 120.4 volts. If we go to the white wire, it is completely neutral. Our Renogy inverter is live. So that's what the problem was. We needed to activate it with 12 volt, and then hopefully we'll do some tests and see if we can run it through its paces. This is the output, this is the input, this is the output. We'll measure the output in a minute, and we see we've got output 119 volts. We just have to go through the system and decide if we have to change any parameters. So now's a good time to read the instruction manual. We now have our Renogy MPPT charging controller fully operative, along with a Bluetooth transmitter. We have 3 bypass switches, shut-off switches, one to the engine, because this charges the engine up to 25 amps, one to the battery, which powers the unit, and one to the solar panels, which provide the charging. Now we also down here have the 3 kilowatt Renogy inverter, which is running right now on shore power, and as you can see, it is charging, slowly charging the battery, We have input of 117 with current loss, cordage drop, and 116 output. Our Bluetooth is operating, showing at 14.4 volts with 13 on the starter battery and 3.48 amp coming in. So the one with the highest charge is supplying it. Since we've only put a minimum 15 amp charge on this, I think what's happening is our panels are taking over. So that's it. Now what we have to do, since this is below one of our aft decks, we have a ladder here which we're going to fit. Before we do that though, we're going to build a acrylic cover for this, which will be a splash shield, and another acrylic cover which will come out to here. And that's on the next project, which is a continuation of the solar project. Our solar wires are coming across the bimini and wire tied and drop down to the center console. There will be another stainless steel tube up there, and here you'll see 4 packing glands for 2 different sets of wires which go down and through the steering pedestal into the engine room. We're charging here. The engine's running at idle 800 RPM, and we're combined charging amps of 10.12 volts, which I suspect is almost all panel. As when we started up, we were charging 25 volts, and then the alternator regulator has calmed down. So everything's running great, sounds good, water's coming out the back end, and looks good. Well, this is the old batteries, 1, 2, 3, 4, and a Pro 3 charger and a battery doctor isolator. Goodbye to the old and hello lithium. I hope it was informative. We're going to be coming up with our next episode of the Seawater Pro. Stay tuned for that one.
And don't forget to hit that subscribe button and like our videos. Thanks, everyone.